Welcome to this platform. So in this video, we are going to answer Science Paper 2 of 2025 that the GCE wrote, that is Chemistry. So we are going to go through the whole paper, and I urge you to stay up to the end. And please, if you're watching this from YouTube, do not forget to subscribe. And if you're watching this from TikTok, you might just be watching part of it. Rush to my YouTube channel and watch the whole video. If you're watching from Facebook, equally visit my YouTube channel with the same name. Okay, so let us look at the question that came. And just for you to know, this time around, all the answers are being written in the question paper. I guess you know those changes. All right, so Science Paper 2, which is Chemistry, is made up of 3 sections. That is Section A, which is multiple choice question. You are supposed to answer all the questions just by choosing which one the best answer, A, B, C, or D, and those options. Then, of course, Section B, we are going to see where you write one word answer or some explanation. So let us look at let us start with Section A. And from Section A, the first question was, Elena accidentally sucks into the mouth a solution of sodium hydroxide during titration. Choose the appropriate action Elena should take. So this is coming from laboratory safety rules. And the appropriate action the learner should take is immediately inform the teacher. The teacher would know the first aid to administer. So immediately inform the what? The teacher. Then question 2, which states of matter exist at the boiling point of a substance? So at the boiling point of substance is where now the substance has changed into gas, but it's still some liquids. So in other words, liquid and gas exist. Question 3, the diagram below shows the changes of state among the 3 states of matter. The diagram below, or the diagram, shows changes of state among the 3 states of matter. As you can see, solid, liquid, gas. Then the change of state, you have the one that are going forward and of course backward as the arrows indicate. What are the questions? Why are the changes called physical, or why are these changes called physical change rather than chemical changes? Why are these changes called physical changes rather than chemical changes? So from this diagram, what I can see are these arrows going forward and backward. This means reversible. So in other words, the reactions, it means that, or this is because they are reversible. They are reversible. Now, the other thing that you need to know is that for the chemical change or the physical change is a change in which no new substance is formed, but chemical change, a new substance is formed. But in this scenario, we are given the diagrams, and what we are able to see is that the reaction is reversible. So there's a conflict between the first answer and the D answer. Produce no new change. That is physical change again. That is true. But in this case, we go for the diagram that are given, what we're able to see. Okay, the fact that we have not been given what a chemical change is, or examples and all that, we are going to choose A to be the best answer because they are saying, why are these changes? Which are those changes? Solid, liquid, gases. Physical or called physical change rather than chemical change. All right, and that is the reason why we conclude that the answer is A. Going for question 4, which of the following is the best method to use to separate sugar crystals from which of the following used to separate sugar crystals from solution during the production of sugar? Which one during the production of sugar? So the one that we go for is crystallization. Crystallization is used to separate sugar crystals from sugar solution. Then 5, Elena accidentally mixes iodine crystal. Now iodine crystal, pay attention, you need to know that it is subrime. So iodine crystal, subrime. Then magnesium chloride is a salt, okay, soluble salt. So Elena accidentally mixes iodine crystal with magnesium chloride. Which method would be suitable to separate this? So the method is sublimation. So you heat the mixture, then iodine crystal will sublime, then you cool them if you want to collect them. So that is the method that is going to be used. So sublimation. Question 6. Which of the following is approximate mass in atomic unit for electrons? Which of the following is approximate mass in atomic unit for electrons? B. 1/1840. That is the answer. Then let us go for question 7. Which of the diagram shows the structure of an atom for element W? The following diagram shows the structure of an atom for an element W. Choose the chemical formula of the compound formed when W reacts with oxygen. So when W reacts with the oxygen has a valence of 2. What about W? W, you look at the electron outside shell, it's just 1. So it has a valence of what? 1. So if you close this, you're going to have W2O. So the answer therefore is C. I guess you know how to do this. If you do not know how to write chemical formulas, chemical equations, how to balance them, I have a video right here on Facebook. If you're watching this from TikTok, still it's there. If you're watching this from YouTube, it is there. So on all these 3 platforms, the video is uploaded, and get to look at that. You learn something. Question 8. Hydrochloric acid is used to clean some metals. Hydrochloric acid is used to clean some metals. The metals react with oxide layer on the surface of metal. Which of the following are products formed? Now, this is an acid reacting with an oxide. Okay, it can be metal oxide, but what we know that this is a base. Okay, then an acid. So what is formed normally is salt and water. So in other words here, the answer is D, salt and water. Okay, so I've answered too many questions from 1 up to 8. You guys, you need to answer 1 as well, or 2. So look at question 9. The result of 3 tests carried out on solution of compound M are shown in the table. The results of 3 tests carried out on solution of compound M are shown in the table. As you can see, the table. So we have test. So for test 1, using aqua sodium hydroxide, what are the results? White precipitate, PPT please, is precipitate. White precipitate form soluble in excess. Then ammonia, aqueous ammonia added, white precipitate forms soluble in excess. Then aqueous hydrochloric acid add, effervescence of a gas that turns lime water milk is produced. So in other words here, these are the tests that are carried out on a certain compound. Now, what is the compound M? What is the compound M? So A, we have aluminium carbonate, we have aluminium chloride, we have zinc carbonate, we have zinc chloride. Now, to give you a clue, a gas that is produced is when an acid reacts with whatever the compound is, produces a gas that turns lime water milk. This is carbon dioxide. So this is carbon dioxide. So this can only be possible if an acid reacts with a metal carbonate. Okay, so which means B and D are not part of the answer. So you're going to check out only A or C. So which one is the answer? Which one is the answer? So this question, get to answer it. Let us go to question 10. 2.4 gram of magnesium ribbon. So 2.4 gram of magnesium ribbon reacted with 2 moles of dilute sulfuric acid. So sulfuric acid. Then this is a metal and an acid. What is formed is a salt, magnesium sulfate, written as such, plus hydrogen gas. Okay. Then they are saying, what is the volume of the gas produced at room temperature and pressure? what is the gas produced at room temperature and pressure. So the gas that is produced is what is the volume of the gas, please? That is produced at RTP. The gas that is produced is hydrogen. Now, how do you find the volume of the gas produced? You are going to use the formula. Volume is equals to given, number of moles is equals to volume given, that is Vm. So the formula that you use right here to find the volume of hydrogen gas that is produced, you are going to use this one. Number of moles is equals to given volume divide molar gas volume, which is just the mass, the volume of 1 mole of a gas. And we are given a condition RTP. Now, room temperature and pressure, Vm in decimeter cubic is 24 decimeter cubic per mole. This is the molar gas volume. Now, for us to find the volume, we are going to say volume is equals to number of moles multiplied by Vm. We already have the Vm, but we need the number of moles of hydrogen. How are you going to find the number of moles of hydrogen? To find the number of hydrogen, since magnesium and hydrogen, sulfuric acid, are reacting, we are going to pick one of these reactant and equate to hydrogen and find the number of moles of hydrogen. That is using mole to mole. But which one do we pick? So we are going to pick the limiting reagent. How do we pick the limiting reagent? We find the number of moles of these and look at which one has less number of moles. So with the information given, number of moles of magnesium is equals to, we are given mass, so mass over molar mass. Magnesium molar mass is 24. So it's just the same as 2.4 divide 24 should be able to give you 0.1. So divide 24. So this is giving me 0.1 moles of, so these are moles of what? Moles of magnesium. Then what about for sulfuric acid? On sulfuric acid, we are given the volume and molarity, which is concentration. So we find the number of moles using concentration. So number of moles is equals to concentration multiplied by volume. Concentration is 2. The volume, we need it in decimeter. Divide by 1,000 is going to give you 0.01. So multiply 0.1. 0.1, not 0.01, 0.1. And this gives us 0.2. So if we are to compare the 0.1 moles and 0.2 moles, already you know that the limiting is magnesium. So we are going to form the ratio of magnesium and hydrogen. So magnesium and hydrogen gas. Now, a mole to mole ratio. What numbers are in front of magnesium and that is hydrogen? It's a 1-to-1 if this equation is balanced. So you have magnesium 1, sulfur 1, oxygen 4, hydrogen 2, hydrogen 2. So the equation is balanced. So you have a 1-to-1 ratio. So which means 1 mole of magnesium react with 1 mole of sulfuric acid to form 1 mole of hydrogen gas. What about 0.1 moles of magnesium? What would be the moles of this one? This is a 1-to-1 ratio. So which means if it's a 1-to-1 ratio, the number of moles of magnesium is equal to the number of moles of what? Number of moles of hydrogen. So therefore, number of moles of hydrogen gas is equals to 0.1. And it's a 1 that we need for us to find the volume. Remember here, so we are going to say 0.1 multiplied by 24. And this gave us 0.2 decimeter, 0.4 decimeter cubic. So the answer therefore here, it is B. So I guess you've gotten the explanation. Although my work seemed to be scattered everywhere, I guess you followed the explanation. So make sure that you look at that. But if you were to use the number of moles of, if you use sulfuric acid and hydrogen gas, you form a ratio, you're still going to find the answer. But one thing you should know is that you always use the limiting reagent. So you need to determine that. Okay? So if we were to use sulfuric acid, you are going to find this. All right. Let us look at question 11. Let us look at question 11. Calcium carbonate thermally decomposes to form calcium oxide and carbon dioxide according to the equation. So as you can see the equation, now they are saying 8.0 gram of calcium carbonate was strongly heated into crucible. This 3.4 gram of calcium oxide remained in crucible. Okay, what was the percentage yield of calcium oxide? 3.4 gram of this remained in crucible. What was the percentage yield of calcium oxide? Now look at this. What is percentage yield? Percentage yield, I'll say percentage yield is equals to actual yield divide calculated yield or theoretical yield or measured. Is it measured? So let me say theoretical yield. So theoretical yield is also called expected yield. Okay, multiply 100. So let us find now the actual yield. Okay, let us find the actual yield. Now to find the actual yield, we are going to form a ratio. We are going to form a ratio of calcium carbonate to calcium oxide. We are going to use mass to mass. These are masses. So we are going to use mass to mass. So find the molar mass of this one and treat it as mass, and that is 100 gram. So 100 gram of calcium carbonate decomposes to produce, the molar mass of this is 56 gram of calcium oxide. What about 8.0 gram of calcium carbonate? It will produce X. So you're going to cross multiply here. You're going to have 100 gram X is equals to 56 gram multiplied by 8.0 gram. Divide 100, divide 100. So X is going to be 56 times 8. 56 times 8 is 448. Divide 100. So this is going to give us 4.48 gram. This is the what? This is the theoretical yield, the calculated yield. This is the theoretical yield. Okay, so now let us find the percentage yield now. Now from the question we are told 8.0 gram of calcium carbonate was strongly heated in the what? In crucible, and 3.4 gram of calcium carbonate remained in the crucible, which means this is what was the actual yield. So the actual yield that was produced is 3.4. So now using this we can say percentage yield, we can replace here. Let me just remove this part. We can replace 3.4 gram divide 4.48 gram multiplied by 100. And when you do this, this should be able to give you 3.4 divide 4.48. Okay, this is giving us 75 multiplied by 100, please. It's giving 75.8, which is 76%. So this is 76%. And from the answers, the answer is A. That is how you do it. All right, up to question, this is question 11, up to question 12. Hydrogen peroxide solution decomposes very slowly at room temperature to produce oxygen and water. Apart from increasing temperature, suggest the best way the reaction can be speeded up. Hydrogen peroxide solution decomposes very slowly at room temperature to produce oxygen and water. Apart from increasing the temperature, suggest the best way the reaction could be speeded up. So this reaction needs a catalyst and a suitable catalyst. So it needs a what? A catalyst. So the answer right here is D. So question 12, the answer is D. Let us go for question 13. The diagram below shows the electronic structure of an ion of L. This is an ionic structure, and you can see positive 3 there, which means this one lost how many? 3 electrons. Which means the outermost shell had how many electrons? If I were to redraw this, had 3 electrons. Outermost shell had 3 electrons. Then they are saying which group and the period of the periodic table does this element belong? Now, you need to know that the group of the periodic table, or the group elements are put in the group depending on the number of electrons in the outside shell, called valence electron. Now, if this one lost 3 electrons, as it is the ion, which means it lost also 1 shell. So this, before it lost 3 electrons, it had 3 shells. So this one belonged to period 3. So you're going for those that have period 3. So automatically this is wrong, this is wrong. Then what about the group number? The group number, okay, so I think I have some mix up here. The period is determined by the number of shells. So you just count the number of shells, 3 of them. Then the group number is determined by the number of electrons in the outside shell. I guess you've gotten the correction. So how many electrons were there in the outside shell? There were 3, those that were lost. So this one belonged to group 3. So group 3, period 3. Group number is determined by the valence electron, which are number of electrons in the outside shell, whereas the period is determined by the number of shells. Number of shells, count them. How many are they? 3. Okay, so here the answer is B. All right, let us proceed to question 14. Which electronic configuration of noble gas used to provide an inert atmosphere in welding? Now, the one that provides an inert atmosphere in welding is argon, and therefore the configuration for argon is B. Okay, so the answer is B. 15. Metal Y was added to iron 2 sulfate solution, and the solution changed from green to colorless. What is the identity of metal Y? What is the identity of metal Y? Now, one thing that you should know, that if the solution changed to colorless, which means ion was displaced in this case, which means magnesium plus ion, that is iron 2 sulfate. Iron 2 sulfate is like this, so which means there was displacement. This, we need, why I'm saying A is the answer, which is magnesium, because in this case magnesium is the only one that is most reactive than iron, so it displaced this in a reaction and therefore formed magnesium sulfate, which is out into this one catalyzing. So because magnesium is more reactive than iron, therefore it can displace iron in the reaction, hence it changed to colorless. So we need the one that is more reactive than iron, and that is magnesium. Question 16. The diagram below shows the stages in manufacture of ammonia fertilizer. So as you know, ammonia fertilizer is manufactured using ammonium gas. So the whole first process is start with the making of ammonia gas, and you know these gases, that is nitrogen and hydrogen, are combined in the this chamber. Then now what is produced is ammonia. So here is ammonia that is produced, and this ammonia is used in making of fertilizer. Now, in the making of ammonia, you know that the compressed air is not completely converted to ammonia at once, but instead you have some of it that remain in form of hydrogen and nitrogen, compressed air. So in other words, not all compressed nitrogen and hydrogen convert to ammonia, but some of it remain, and it is taken back to the converter chamber so that it can be converted to ammonia. So here we have where insoluble unreacted hydrogen and nitrogen being recycled. I guess you get the thing here, okay? And the diagram is not confusing. So the question is, what is happening in the process labeled Y? So what is happening is that the unreacted hydrogen, and nitrogen are recycled. This is what we call Haber process. So up to here is called Haber process. Up to here, there's ammonia being formed. So very important you understand this part. Then question 17, methane is reacted with steam in the presence of nickel as a catalyst to produce gas T and carbon dioxide. Methane is reacted with steam in the presence of nickel as a catalyst to produce gas T and carbon dioxide. Now, this is what we call steam reforming. Okay, so in this case, we are looking at the making of hydrogen. So the gas that is being made is hydrogen. Now, if you look at hydrogen, it's less dense than air. So what is a suitable method for correction of gas T, and the reason? So upward delivery, and the reason is that more dense than air. So we're going to cancel out those that are more dense than air and just remain with B and C. So now B is upward delivery, then D is downward. So the answer is D, downward delivery and less dense than air. Very important to understand this. Then up to question 18. Pollutant gases are released by the bacterial decay of vegetable matter or vegetable matter. Which gas is mainly sourced from decay of vegetable matter? Pollutant gases are released by the bacterial decay of vegetative matter. Which gas is mainly sourced from decay of vegetative matter? So decay of vegetative matter or organisms, animals, what is produced is methane. It's produced in small amount. Question 19, butene can undergo additional reaction with steam to form compound R. So this is hydration reaction. Now the question is, what is the name of the compound formed? So butene forms an alcohol which is butanol. So the answer is B. And of course, at this point, you should know that I've recorded organic chemistry lessons, the whole topic. The videos are in parts. You should be able to find them on this platform. And there's a video of organic chemistry specifically answering question, which is about 3 hours. That video is right here on this platform. You should be able to find it if you need further understanding on this particular part. All right, let us proceed to question 20. Polymers are made using polymers are made using monomers. The following are the structures of some monomers. The polymers are made using monomers. The following are structures of some monomers. So here are the structures that you can see. W, X, Y, Z. Identify the correct set of monomers that form polyamide linkage. So polyamide linkage is formed when the amino group react with the carboxylic group. So we are looking for the one that has an amino group. Okay, so in this case right here, the answer that we go for is A, Y, and Z. This is an amino group, and this is the carboxylic group. So when these react, water is removed, and of course in the process it forms amide linkage. And make sure that you know the macromolecules where you find amide linkage. All right, so that was section A. All right, so we've spent about 30 minutes just answering section A, and it is because of some calculations. This paper total is 2 hours, and the target is to finish it before 2 hours. So make sure that you are fast and accurate. All right, let us dive into section B now. So look at section B. So in this one, 45 marks, and you're answering all questions. You write your answer in the spaces provided in this section paper or question paper. All right, so let us start section B, and the first question came from that is challenges associated with industrial activities or chemical industrial activities. So there are various changes or challenges caused by chemical industrial activities. There are various challenges caused by chemical industrial activities. State one challenge caused by chemical industrial activities on land. So one of them is cause land degradation. Cause land degradation. The reduce in value of land due to chemicals. Also, you can talk of it cause water pollution. It pollutes water, groundwater, okay, due to the chemicals. Then also you can talk of soil acidity. All these are the challenges caused by chemical industrial activities on land. So make sure that you're able to answer this part. Suggest a method you would use to minimize the challenge you have stated above. So one, what cause these are chemicals? So treating the chemical, so you treat them, treating chemicals from industries. So from industries before discharging them, okay, before discharging them to the environment, okay. So treating the chemicals from the industry before discharging them, and the reason for treating is just to reduce the chemicals that might be in this discharge. Then we go to question B. The model labeled A, B, and C are of three states of matter. The melting and the boiling point of a substance E are also shown in the table. So look at this substance E. We have the melting point. It melts at -114 degree. Then the boiling at 79. What are the questions? Which model represents the states of substance E at the temperature of pure ice? So temperature of pure ice, we are looking at this being in solid form. So which one? You can see here, they are regularly arranged. So this one is the one that is in solid form. So we can write model A. Then temperature of the pure boiling water at sea level. So boiling water, you expect it to be in gas form. So that is C. So C. Then room temperature. Room temperature, you expect to find it in liquid state. Okay. So in other words, that is the, what is that? B. Okay. So here you put B, model B. I guess up to this point we are together. Here I can just put A, okay, because it's already stated which model represent the states of substance E at T. Okay. Let us go to question B2. The electronic configuration of J is 2, 8, 18, 18, 1. J is not the actual chemical symbol of an element on the periodic table. The group or group of the periodic table in which group of the periodic table is J found? Explain why. In which group of the periodic table is J found? Explain why. So the group number, we said you just look at the number of electrons in the outside shell. So this one belongs to group 1. Okay, you use Roman numeral. So group 1, what is the explanation? Because it has 1 valence electron. Or you can say because it has 1 electron in the outermost shell. It has 1 electron in the outermost shell. Okay, that is the answer. Then in which period, that is 2 of A, in which period of the periodic table is J found? So for the period, you count the number of shells. How many are they? 1, 2, 3, 4, 5. This, it means that in the first shell there are 2 electrons, please. Second one, there are 8. Third, 18. Fourth, 18. Fifth, 1. So there are how many? 1, 2, 3, 4, 5. So this one belongs to period 5. What is the reason? Because it has a total number of 5 shells. Okay, so the number of shells determine the period you find the element. Let us go to question B. Name an element in group 7. Name an element in group 7 which is in the same period as element J. Okay, so you go on the periodic table, move in the same period. So period what? 5. So you draw a line in period 5. Then you go in group 7, you draw a line where they are meeting, surely you find it. Okay, that is how you look at it. So in other words here, the element is tellurium. That is the tellurium, this element. I guess you'll be able to do that and be able to answer these questions correctly. All right, let us go to B3. Anhydrous ion 3 chloride, which is this one, salt, can be prepared by reacting hot iron, metal, and chlorine gas in a combustion tube. Anhydrous ion 3 chloride salt can be prepared by reacting hot iron, metal, and chlorine gas in a combustion tube. What does the term anhydrous means? What does the term anhydrous mean? What does the term anhydrous mean? Okay, so anhydrous means water free. Okay, water free. So this lacks water. That is, lacks water molecule. Anhydrous, hydrated, has water of crystallization. Or we can say lacks water of crystallization, or water free. That is what we call anhydrous, or does not contain water. I guess you are good on this part. State the method by which iron 3 chloride is prepared. So look at this. You are reacting metal ion direct with chlorine. So this is called direct reaction or direct synthesis. Direct reaction or synthesis. So direct reaction or direct synthesis. Write the balanced chemical equation for the reaction between iron metal and chlorine gas to form iron 3 chloride. So want to write the chemical equation. So iron, in this case iron 3, it means it has a valence of 3. So iron 3, okay, react with chlorine. Okay, react with what? Oh, iron 3 chloride. Is iron 3 chloride, please? No, iron react with chlorine. So iron, which is solid, react with chlorine. Chlorine is a diatomic, so you present it like that, which is a gas. Now, what is going to form? What is formed is the iron. Now, iron has the valence of 3. You can see from the compound, iron 3, so has a valence of 3. So, has a valence of 3, and chlorine has a valence of 1. So, it's going to be like this. Okay, that is what is produced, which is a solid. Now, is this balanced? No, it's not balanced. Look at iron. Iron here, there's 1. Iron, there's 1. Okay. Then, chlorine here, there's 2. Chlorine here, there's 3. So, what do? We put a 3 here to make chlorine 6, which means here we are going to put a 2 to make chlorine 6. And here we are going to put a 2 to make iron 2. Look at this, iron 2, iron 2. Chlorine 6, that is 2 multiplied by this 3. Then that. If you don't know how to write a balanced chemical equation, I have also the video dedicated just on this part, right on this platform. Have a look at it before you go in an exam or you write a test. So this is the balanced chemical equation, and this earns us 2 marks. So please counter check this as you go through. Then B, describe what would be observed if sodium hydroxide solution, that is the sodium hydroxide solution, was added drop by drop to solution of iron 3 chloride in a test tube. So what will be observed is that a brown precipitate would form. So a brown precipitate would form because of a reaction that is taking place. Okay, so a brown precipitate would form. Okay, let us go to question B4. 400 grams of impure iron 3 oxide reacted with 600 cubic centimeter cubic of 0.100 mole per decimeter cubic sulfuric acid. Construct the balanced chemical equation for the reaction. State symbols are not necessary or required. So here, what is reacting? Iron 3 oxide. How do you write iron 3 oxide? You know that iron is Fe and oxide is O. This has valence of 3, has valence of 2. So iron 3 oxide is written as the Fe2O3. Reacting with what? Sulfuric acid. Sulfuric acid is the SO4. That is S2O, H2SO4. Okay? What is going to form? So this is a base and an acid. So what you are likely to form is salt and water. So in this case, what is going to form is a salt, of which iron is going to displace that. So we are going to have FeSO4 plus water. Okay, that is what we are going to have. Now, how about this is iron 3, so we are going to have, not this one please. So this is iron 3, so iron has a valence of 3, so it's like iron valence of 3, then sulfate as a radical valence of 2. So we are going to have Fe2SO4, then 3. That is the salt that you're going to produce, and water. Then now to balance this one, we just add a 3 here in front of water, and also a 3 in front of sulfuric acid, and also, let us check, hydrogen 6, oxygen here 3 plus 4, 3 plus 12, this is 12, it's multiplying this is 12, so 3 plus 12, that is 15, this is 3 plus that is 12, that is 15. So this is the balanced equation that we can write on this part. Then B, calculate the mass of pure oxide that reacted with an acid. So let us calculate the mass. Now for us to calculate the mass of the pure oxide, we form a ratio of iron 2 or 3. Okay, that is the ratio that we are forming. 2, 3 sulfuric acid. Now look at this. 1 mole of this iron oxide react with 3 moles of sulfuric acid. Now we want to find the moles of pure. So this one we don't know, but we can find the moles of sulfuric acid. What are we given on sulfuric acid? Concentration. So we are going to use concentration is equals to, we are going to say number of moles is equals to, let me just put it in, number of moles is equals to concentration multiplied by volume. So what is the volume? Volume, we need it in decimeter cubic, so divide by 1000, so it's 0.6 multiply by, what is the concentration? 0.1. Multiply this, you're going to have 0.06. These are the number of moles of sulfuric acid. Okay, so we are saying 1 mole of iron oxide react with 3 moles of sulfuric acid. What about these moles of sulfuric acid? What will be the mole of this one? And these moles that we are looking at are the moles, or the moles that we are finding are the moles of a pure oxide. Okay, the one that react with sulfuric acid. So we cross multiply. We are going to have 3x is equals to 0.06. Divide 3. divide 3. X is equals to 0.02 moles. These are the moles of what? These are the moles of pure oxide. Now that we have the moles, we can now go on and find its mass. Number of moles is equals to given mass over molar mass. So to find the mass, we are going to say mass is equals to number of moles multiplied by molar mass. Now here, number of moles of what? Number of moles of iron oxide, 0.02, multiplied by what is the molar mass of iron? What is the molar mass of iron? That is the oxide. This is 3 multiplied by 16, which is 48. Then iron, one iron is 56, but there are 2 of them, so 56 times 2, that is 112. So 148 plus 112. 112 plus 48. What is the total? 160 gram per mole. Now that we found that, we can multiply here 160. Then what are we going to find? 0.02 multiply 160. So if you multiply 160, we are going to find 3.2 gram. So this is the mass of the pure oxide. Then percentage purity of iron 3 oxide. So percentage purity is equals to mass of the pure substance, mass of pure substance, divide mass of impure or mixture. Now, multiply by 100, please. So mass of the pure, we found 3.2 gram. Divide the impure is given 4.0 of impure. So impure is 4.0 gram. Multiply by 100. So 3.2 divide 4.0, which is 0.8. Multiply by 100, this is 80%. So the percentage purity of this is 80%. I guess up to this point we are together. Just to emphasize more concept, I've recorded everything as well. All the lessons are available on this platform, including questions answered. So make sure that you look out for that. Otherwise, we can proceed. We go to question 5 now. Study the sketch of the periodic table shown and answer the question that follows. Note, the symbol of element given in the sketch are not the actual symbol of elements, as you can see the diagram. The first question here, elements K, L, and P are all metals. Which among these is most metallic element? Explain why. Which among these is most metallic, and explain why. Okay, so which one is most metallic? Now, what do you need to know? As you go down the group, the metallic nature of the metals increases. So you have the one that is down here to be the most metal if you are in this group. Then as you go this side, the metallic nature reduces because you are approaching non-metals. So going down the group, the metallic nature increases. And therefore, if you are to compare L, K, and P, look at this. The one at the bottom is K. So is element K. What is the reason? Metallic nature of elements increases going down the group and reduces along the period to the right. Okay. Then state one use of element S. So element S, as you can see, is in the first period, and the elements that you find in the first period is hydrogen and helium. So in other words, what is the use of helium? So used to fuel hot air balloons. Hot air balloons. And the reason is because it is less dense than air. I've written this not to be part of the answer, but in the case you meet such a question, so the answer just needed to end on it because or it is used to fill hot air balloon. Okay. Explain how various properties and some metals have various properties and some harmful effects on humans. Explain why. Alright, so after answering all the questions that I've answered per tradition, one question is given to you to answer. So this is question 5, B2. So when you're answering, you indicate question 5, B2 and put your answer. So that answer, I'll expect the answer in the comment section and everyone should be able to or will be able to learn from you. So please make sure that you answer this question. Let us proceed to question 6. Names of metals that forms part of the reactivity series are listed as aluminium, iron, gold, lead, sodium. Arrange the metals in the increasing order of reactivity, starting with the least reactive at the top and the most reactive at the bottom. So, how is this going to be? So, you are going down in terms of listing. So, least reactive at the top. So, you start gold is the least reactive, then followed by lead is the next least reactive, then followed by what? Followed by iron, then aluminium, then the most reactive is the sodium. I guess you know things on metal, or I guess you know this topic very well. But very soon, I think I'll get to put up a lesson just on this particular part. So be expectant. All right. From the list, that is A2, from the list given, identify the metal whose hydroxide does not undergo thermal decomposition. So, the oxide of most reactive metal does not undergo decomposition easily. So, in other words, here is an oxide of, is a hydroxide of sodium because it is stable and therefore it does not go or undergo thermal decomposition even if we were to heat it. So from this list given, identify the metal whose metal hydroxide does not undergo thermal decomposition. So the most reactive one is the one that has stable hydroxide and therefore it is sodium. Explain why aluminium is said to be unreactive despite its position in the reactivity series. So why is it so? So aluminium easily reacts with oxygen, forming aluminium oxide, which is a protective layer, making aluminium unreactive. So we can say it easily reacts with oxygen, forming a layer of aluminium oxide. Hence, its non-reactivity. Okay, so it easily reacts with oxygen, forming a layer of aluminium oxide, making aluminium unreactive. Okay, so there are different ways you can explain this one. So please also I would like to hear from you. Make sure that you indicate that you're answering. This is question 6B. Okay, so let us proceed to look at now B7. Figure 7.1 shows two allotropes of the compound, as you can see. Then now, the first question is define allotropes. So allotropes are just molecules. So you can say molecules that consist of atoms of one element but have different structures and geometric shapes. Okay, so allotropes are molecules that contain atoms or consist of atoms of the same element but have different structure and geometric shape, or you can say are elements in different physical form but in the same state. Different physical form but in the same state. So that is what we call allotropes. Now, which of the two allotropes, A or B, conduct electricity? Now, these are allotropes of carbon, okay? And we have graphite and diamond here. So this is the graphite, and graphite conduct electricity. This is the diamond. I guess you remember these structures, okay? So which one conduct electricity is the B. So the one that conduct electricity is allotrope B. Explain your answer. So because of free moving electrons were in between the layers, okay, of carbon atoms. So that is the answer to this question. So explain why. Which of the two allotropes, A or B, conduct electricity? And we are saying it's B. Explain why. Because of free moving electron in between the layers of carbon atoms. Give one difference other than conduction of electricity between allotrope A and B. Give one difference other than conduction of electricity between allotrope A and B. So what is other difference? So allotrope B is used in electrode, so we can say allotrope B is used in electrode, in electrolysis, while allotrope A is used for cutting. Allotrope B is used for cutting, or is used for making cutting tools and drilling. So cutting tools and drilling. Okay. Then C, give one use of carbon dioxide. So this is general. One use of carbon dioxide. It's not natural use, it's not artificial, but just one use. So used in baking, used by plants, that is the natural use, by plants during photosynthesis. So used by plants during photosynthesis. Okay. Then used in making carbonated drinks. You can put all those. So please make sure that you look at this part as well. All right, let us look at B8. The diagram below shows the reaction of butanoic acid. So, which means we know that this is an acid called butanoic acid. Okay, so what are the questions that follows? What are the questions that follows on this reaction? So, the first question is that A, B, C, and D are different substances. Identify A, B, C, and D. So we are simply identifying the substance A, B, and C. Now look at this. Very important to start the reaction. So it means butanoic acid react with the sodium, result into A and B. Then when it react with sodium carbonate, it result into B, C, and D. Now, this is an acid, even if it's a weak acid. Generally, when an acid react with a metal, which is sodium, it produces a gas, which is hydrogen, and a salt. So here, the gas is the hydrogen. So the gas, we can say, is the hydrogen. So the substance is hydrogen gas. Okay, then substance B is a salt. Now, butanoic acid and sodium. It forms what we call sodium butanoate. Butanoate. So this is called sodium butano. Let me just write this properly. This is called this is hydrogen gas. This is the sodium butanoate. Then C, here a carbonate, when it reacts with the acid, it forms three things: a salt, carbon dioxide, and water. So a salt, it is still, because of sodium, it is still sodium butanoate. That is the reason why these are BB. So they are both sodium butanoate. Then C, gas C is carbon dioxide. So this is the carbon dioxide. I guess there's no one who is lost up to this point. Then D is liquid, which is the water. Okay, so in both cases, even here, when a methanol is heated, okay, heated with methanol, in other words, the acid react with methanol, that is an alcohol plus an acid, resulting to an ester, and what is produced is an ester and water. So D is water because it's a liquid D. Then organic liquid E. Organic liquid E is an ester. And what is the name of an ester? This is butanoic acid. This is methanol. So it's methyl butanoate. I guess we'll find the question where we have to answer this one. So butanoate. So that is how we answer the first question. Now, B, name and draw the displayed structure of E. Look at this. So this that is formed is an ester. Now for an ester, the first part of the name comes from the alcohol. Then the second part comes from an acid. So the alcohol is methanol. So it becomes methyl. Then the acid is butanol, become butanoate. Or butanoic acid become butanoate. So this is methyl butanoate. Now what is the structure? So the structure for this one, we are going to start by putting up the diagram for methanol. So methanol has one carbon, looks like this. Okay, then this other side we'll put an acid which is the butanoic acid. Butanoic acid has 3 carbons. So very important to understand that the first acid in series, which is methanoic acid, has 0 carbon, and it's just like this. Then the second one in series is the one that has 1 carbon. So we do not count this as number of carbon because it's part of the group. This is the group. So the second one has 1 carbon. Okay, has 1 carbon, which is simply this one. Okay, so butanoic acid has 3 carbons. So 1, 2, 3, like this. Hydrogens around, hydrogen, and also here hydrogen. So looks like this. Okay, now the reaction takes place. This contribute OH, this one just H, and water molecule is removed. Okay, H2O. So what we are interested is just the structure of the product. So how is it going to be? So it's going to be like this: carbon, hydrogen, hydrogen, then carbon. This is how it is going to be. Okay, going to be like this. Okay, so this is how the structure of the compound going to be. Okay, all right, I guess there's no problem up to this point. We proceed to the question 9. The table below shows the result of the relation between copper 2 carbonate and excess dilute nitric acid. So when these were reacted, the volume of a gas per time 0, 10, 20, 30, 40, 50, 60, you can see that is time. Then the volume of a gas produced. Determine the total volume of a gas, carbon dioxide. Determine the total volume of carbon dioxide produced. So when copper 2 carbonate reacted with nitric acid, the gas produced is carbon dioxide. Now what they're saying is that determine the total volume. So for total volume, we just look at the last number here, and that is 50. What are the units? Centimeter cubic. Then calculate the average rate of reaction. So rate of reaction, that is average rate of reaction, is equals to total volume produced, or total volume of a gas evolved, divide total time. So the total time is that total volume is 50. So you're going to say 50 cubic divide 60 seconds, and we are going to have 0.83, that is the cubic, okay, second. That is the average rate of reaction. Then B, rock salt is the impure form of sodium chloride in nature. Briefly explain how you would obtain solution of sodium chloride from a sample of rock salt. So how would you obtain it? So 1, crush the rock salt into smaller pieces. Then dissolve the crushed rock salt in water. Then stir to ensure dissolution. So stir to ensure dissolution. Then filter the solution to remove insoluble impurities. Okay, so that is how you can obtain. They are saying briefly explain how you would obtain a solution of sodium chloride from a sample of rock salt. So this is exactly what you do. So crush the rock salt into smaller pieces, dissolve the crushed rock salt into water, stir to ensure dissolution, filter the solution to remove impurities, and finally you have the solution. Then name the method used to prepare sodium chloride in the laboratory. So method that can be used is titration method. Okay, so that is how you answer this question. We proceed to look at section C now. So we are done with the section A and section B in exactly 1 hour. Let us look at section C. Now, for section C, we start with C1. What about C1? So this time around, please, another thing that I'll update you is that you write from here. So read the instructions. So you write from the paper this time around. No separate answer booklet. So answer any two questions from this section in the space provided from 15 to 19. So the space for this question is on page 15 to 19. Pay attention to that. If you write on the different, or if you write your work is not in order, you might lose out some marks. So make sure that you read the instruction. Now let us look at the first question here. Elena prepared carbon dioxide in the laboratory by reacting 20 grams of marble chips with 1.0, that is concentration of hydrochloric acid. Now, marble chips is calcium carbonate. You need to know that. They are saying construct the balanced chemical equation for the reaction. So, let us construct it. So, how is it going to be? Calcium carbonate, I hope it will fit here, solid, reacting with calcium carbonate, reacting with hydrochloric acid, HCl, which is aqueous. This results into the formation of calcium chloride as a salt, plus, which is aqueous as well, plus carbon dioxide gas, plus H2O as water. Now, is this balanced? No. Let us balance it. So to balance it, chlorine is 2, so we put a 2 there. Let us check. Hydrogen 2 there on water. What about calcium? Calcium 1, calcium 1. Carbon 1, carbon 1. Oxygen, here there's 3. Here there's 2, then plus that one on water, 3. So this is the balanced chemical equation for the reaction. I guess you are able to see clearly. Then the second question, the rate of reaction for this reaction can be increased by altering some factors other than temperature and catalyst. State 2 other factors that would increase the rate of chemical reaction. So this is on rate of chemical reaction. So other factors, we have other factors such as the concentration. Okay, so concentration of a substance, and you need to know how it does that. Then you need to talk of pressure. Then of course you can put also surface area. Okay, surface area. So these, any of these two, but make sure that as you write, please you present them very well. You can put Roman numeral for 1, 2, then 3. So you number them like that clearly. All right, I guess there's no problem. Then C, the presence of catalyst can lead to increase in the rate of reaction. How does a catalyst increase the rate of reaction? So it increases the rate of reaction by lowering activation, so lowering activation energy. Okay, that is how it increases the rate of chemical reaction. Then question D, the carbon dioxide gas produced was bubbled through lime water, which turned milky. The first question is, write the chemical formula of a compound that was produced that caused the lime water to turn milky. So this is the answer to D1. Okay, D1. So we are looking at calcium hydroxide. So calcium hydroxide reacting with carbon dioxide, then resulting to calcium carbonate. So it is the calcium carbonate which forms a white precipitate plus water. Okay, so calcium plus water. So here we are saying calcium oxide plus carbon dioxide plus, so plus water. Now the question is it balanced? What do you have here? Calcium 1, calcium 1. Carbon 1, carbon 1. Oxygen, we have 3 here, plus that one 4. We have 2 here, we have 2 here. Hydrogen, we have 2, so this is balanced. Okay. Then we are told again that in the B, more carbon dioxide was bubbled into the lime water that turned milky and it became colorless. Write the balanced chemical equation for the reaction. So, further carbon dioxide or more carbon dioxide was added to this water that turned milky. Now, they are asking us to write the chemical equation. So, I'm going to put D2 right here for lack of space. So, how is it going to be? So, calcium hydroxide plus carbon dioxide. So this one will result into formation of now what we call bicarbonate. Something like this. Bicarbonate, which is the aqueous. So this one is C, please. Oh, so this is bicarbonate that is formed. Okay, so this, to balance it, you add a 2 here. I guess it's balanced now. So this is the further reaction. So when this lime water that turned milkish or more carbon dioxide is added, or we are saying more carbon dioxide was bubbled into the lime water that turned milky and it became colorless. Write the balanced chemical equation for the reaction. So this is the balanced chemical equation where more carbon dioxide is added, resulting to bicarbonate. Okay. All right. Then E question. Explain why solid carbon dioxide, known as dry ice, undergo sublimation. Explain why solid carbon dioxide, known as dry ice, undergo sublimation. So this question, I'll leave it to you to answer it. So make sure that you indicate this is C1, question E. Very important. So what is the reason? I guess you've seen how the answers are moving. This is D2. Make sure that as you go through, you just write down the answers. Otherwise, you can proceed to C2. Okay? Now, what about C2? What do we need to know about C2? So, for C2, it requires a lot of space for us to write. But anyway, we're going to see how we're going to work this one out. So silver chloride is an insoluble salt which can be prepared by reacting aqueous chloride with silver nitrate. Then they are saying, describe how the dry and fairly pure sample of silver chloride can be prepared in the laboratory. 4 marks. So this one requires us to explain. Describe how the dry and fairly pure sample of silver chloride can be prepared in the laboratory. So we are going to go to the spaces. So we're going to use this space that is for C2. So for C2, we are answering question E. That is question A. So C2A. So here. So how is it? So 1, mixed aqueous. So mixed aqueous solution of sodium chloride, which is the NaCl, and silver nitrate, which is the silver is Ag, NO3, silver nitrate, in a beaker. So mix aqueous solution of sodium chloride and silver nitrate in the beaker. Then white precipitate of silver chloride forms. Okay. Then now what happened? I can even Okay, white precipitate of silver nitrate forms. Then filter the mixture. So filter the mixture using filter paper and of course and a funnel. using filter paper and a funnel to separate Ag chloride, which is the silver chloride, precipitate and wash the precipitate with distilled water. Finally, dry the precipitate in an oven. So, what is the question again? Let us go back. Describe how the dry and fairly pure sample of sodium chloride can be prepared in the laboratory. So here is the process. That is C1. C2, we are answering question A. Mix the aqueous solution of sodium chloride. So aqueous solution of sodium chloride and silver nitrate in a beaker. White precipitate of silver chloride forms. Filter the mixture using filter paper to separate silver chloride precipitate and wash the precipitate with distilled water, and finally dry the precipitate in an oven. So this is the process. This ends you 4 marks. Let us go to the second question now. So for a second question of C2, write the net ionic equation for the reaction. Write the net ionic equation for the reaction in one include state symbols. So for this reaction that is occurring in the first part, the reaction first is the sodium chloride, which is aqueous, plus that is the silver nitrate, which is the aqueous. This results into the formation of silver chloride, which is aqueous, plus sodium nitrate, which is also aqueous. These are the products that are formed. Now, the big question here, we are told to write the net ionic equation. So net ionic equation, we know that, is this balanced, please? So we write from the balanced equation. So this is balanced. So sodium chloride, aqueous, plus silver nitrate, which is aqueous, then resulting into silver chloride, which is the aqueous, plus nitrate, that is sodium nitrate, which is the aqueous. So we split the one that has the one that are in aqueous. We split the one that are in aqueous. Okay, so here this is not in aqueous, please. This is in solid. So we split those that are in aqueous. So this side, the one that are in aqueous is sodium chloride. It's going to be aqueous, that is sodium chloride, plus chlorine or chloride ion, that is aqueous, plus Ag, that is aqueous. Okay, that is the aqueous. Then plus nitrate, that is the aqueous. Then on the other side, this one remains Ag chloride, which is solid. Then we split this one, aqueous, that is that. Then plus nitrate, which is the aqueous. So now we cancel out what is common on both sides. So sodium and sodium. Chloride, do we have chloride on the other side? No. What is common here? Nitrate. What remains? Chloride ion, which is aqueous, plus Ag, okay, aqueous, then result into which is Ag chloride, which is the solid. So this is the net ionic equation. Alright, I guess there's no problem up to this point. We are going to question C now, of C2. Use your equation in B To calculate the number of silver chloride expected, use your equation in B to calculate the mass of silver chloride expected if 1.7 gram of was reacted with excess sodium hydroxide. So expected, we are calculating the theoretical yield. So this is the question C. Now, here they are saying expected mass of, from this equation, expected mass of sodium chloride, I guess. Yeah, expected mass of silver chloride. Mass of silver chloride expected. 1 point of silver nitrate was reacted. So we are forming the equation of silver nitrate. So silver nitrate, Ag nitrate to Ag chloride. Okay, so want to find the mass. Now here we are going to use what we call mass to mass. We find the molar mass of this one, we treat it as mass, and also that one as mass. So the molar mass of Ag nitrate, Ag is 108 plus nitrogen is 14 plus oxygen, there are 3 of them, 48. This one should be able to give us 108. Is it 108? This is 108, please. Not 180, 108. This should be able to give us 170. Confirm as you are going through. So this is 170. And some of you might be asking, where are we getting 170? 170 is just the molar mass of silver nitrate. Nitrate has a mass of 108. Nitrogen has 14. Oxygen, there are 3 of them, 48. So we have 170 gram of silver nitrate from what is the mass of Ag chloride? 108 plus 35.5. This is giving us 143. So 143.5 gram. So 170 gram of silver nitrate react to form 143.5 gram of silver chloride. Now, what about 1.7 gram? We are given here. They are saying, calculate the mass of silver chloride expected if 1.7 gram of silver nitrate reacted with excess. So, 1.7 gram, how many of, or what is the amount of silver chloride that will be produced? So, cross multiply. So, we are going to have 170 x or gram, x is equals to 143.5 gram multiplied by 1.7 gram. So this divide 170 gram divide 170 gram. This x is equals to 143 multiplied by 1.7, then divide 170. Should be able to give us 1.435 gram. Confirm if that is what you're finding. Otherwise, this is the mass of Ag chloride produced. So this is what you call theoretical what? Theoretical yield. Okay, so now that is what, or that is how we calculate this question. Then calculate the percentage yield if 0.95 of silver chloride was obtained. So this is the amount obtained, which is the actual yield. So actual yield. So to calculate the percentage yield, we are going to go, that is this is question what? Is it question C? Question C, question D, the last question. So we are going to say T is equals to percentage yield is equals to actual yield divide theoretical yield multiplied by what? 100%. So what is the actual yield? 0.95 gram over theoretical 1.435 gram multiplied by 100. Okay, multiply by 100, able to find 66%. Confirm if that is the answer that you're finding. Otherwise, that is what we needed to write on this C2 question. That answers the whole question. Let us go back to the last question now, organic chemistry. Use the displayed structure to show the answer that, or use the displayed structure to show answer. Use the displayed structure, please, shown to answer the question that follows. So the first question is, name the organic compound shown. So what is the name of the organic compound? Just from this functional group, this is a carboxylic, but it has one carbon. So what is the carboxylic acid with one carbon? It's not methanoic, it's ethanoic. So this is the ethanoic acid. To which homologous acid does it belong? Carboxylic acid. Ethanol is an organic compound which belongs to the homologous series known as alcohol. Draw the displayed structure of ethanol. So ethanol has two carbon and of course OH. So this is how you look at it. Okay, so that is the structure. What term is used to describe the manufacture of ethanol from ethene? That is the hydration reaction. Then we go to see butyl propanoate is an ester. Name two reagents used to form. So butyl butanoate or propanoate. You know that an ester, the first part of the name comes from alcohol. So here we have butyl, which means the alcohol was butanol. So 1 butanol. Then propanoate, the acid, propanoic acid. So propanoic acid. That is butyl propanoate. Describe the chemical test of the minor product of esterification. So the minor product of esterification is water. So what is the identity test for water? It turns white. It turns white anhydrous. Turns white anhydrous copper to sulfate blue. It turns white anhydrous copper to sulfate blue. Or you can say using white hydrous copper to sulfate. The presence of water turns white anhydrous copper to sulfate blue. So that is how you write this one. Then state two uses of esters. So this is the question D, Roman numeral 2. Roman numeral 1. What are the uses of esters? So esters have wider uses in making of soap, making of perfumes, making of flavoring reagent, such as spice. Okay, then the last now, give one similarity between esterification and neutralization. So in both reaction, water molecule is produced. Okay, in both cases water molecule is produced, which is a neutral compound. All right, so this brings us to the end of the presentation. So the paper is supposed to be written in 1 hour. We've spent in 2 hours. You're supposed to write this in 2 hours. We have spent about 1 hour 30 minutes just answering this. So please, if you are here up to the end, do not forget to share this video with your friend. Do not forget to subscribe to this YouTube channel, and make sure that you turn on the notification bell. More video to come for revision. Now, before I go, I offer online lessons. In mathematics, chemistry, physics, biology, and chemistry. That is chemistry, biology. Okay, we've come to the end of the revision, so please do not forget to subscribe to this YouTube channel if you've stayed up to this point. Do not forget also to share with the others. Now, before I go, we offer intensive online lessons. For those that want to register for revision and also those that are writing GCE, you can still register with us. So the subject offered are mathematics, biology, chemistry, physics. So if you're interested to join us, you can just WhatsApp the number 0976 402563. Otherwise, see you in the next one.